Have you ever wondered why a factory is built in one specific spot instead of another? Or what drives a company to locate its operations from its raw materials? Understanding these decisions requires a systematic approach, a framework that helps explain the rationale behind industrial placement. The foundational framework that defines industrial location theory is Alfred Weber's least cost theory, often referred to as Weberian industrial location theory. This theory seeks to explain and predict the optimal geographical location for an industrial facility by minimizing production and distribution expenses, making it a cornerstone for understanding industrial geography. At its core, Weber's theory is built upon the principle of cost minimization, specifically focusing on three key factors: transportation costs, labor costs, and agglomeration. The most significant of these are transportation costs, which include both moving raw materials to the factory and distributing finished products to the market. Weber posited that industries tend to gravitate towards locations where the combined cost of these movements is at its lowest. To illustrate this, consider the nature of the raw materials and the final product. If a manufacturing process involves weight-losing raw materials, meaning the final product is lighter than the sum of its inputs, the factory will likely locate near the raw material source to reduce inbound shipping costs. Conversely, for weight-gaining industries, where the product becomes heavier or more perishable after manufacturing, the optimal location is often closer to the market. Beyond transportation, labor costs play a crucial role. Weber recognized that lower wages could offset higher transportation costs to a certain extent, creating a range of possible locations. Lastly, agglomeration, which refers to the benefits gained by industries locating close to one another, such as shared infrastructure or specialized labor pools, can also influence the final site selection. Although developed over a century ago, Weber's least cost theory remains highly relevant as an analytical tool, offering a systematic way to think about the primary cost drivers of industrial location. It provides a baseline for evaluating how various inputs and outputs influence a business's spatial decisions. A key concept in Weber's model is the use of isodappings, which are lines connecting points of equal total transportation costs on a map. These lines help visualize the geographic area where a particular factory location would incur similar overall transport expenses, providing a practical method for finding the least cost site. Understanding these theoretical underpinnings helps us analyze modern supply chains and production networks. Ultimately, Weber's least cost theory offers a powerful lens through which to understand the complex interplay of economic factors shaping industrial landscapes. It highlights that strategic location is not arbitrary, but a carefully calculated decision driven by minimizing costs to achieve maximum efficiency and profitability, providing essential insights for economic geography students.